Yeah, hello everyone. First of all, I would like to thank you for joining today's webinar on migration, disaster recovery, and backup made easy using RackWare RMM. Yes, so RMM stands for RackWare Migration Module. So before we go ahead, let me quickly introduce you to today's webinar speakers. So Subodh Kane, so he is the Senior Director of Software Engineering at RackWare. Akash Bambal, so Director of QA and System Engineering at RackWare, and Sunil Dev, so he's the India head at RackWare. And before we proceed, let me walk you through today's webinar agenda. So we'll start with RackWare as an organization, where what we do, who we are, and then the RMM use cases, RMM setup, how to set up, and then the migration workflow overview, and then you will be study the some advanced capabilities about the product, and then we can open the Q&A discussion. Yeah, so to proceed further, Subodh, over to you, and thank you.
Hey, thanks, Paresh. Hello, everyone. Welcome all, and thank you for joining the webinar today. I'm Subodh Kane. I'm Senior Director of Engineering at RackWare. So, RackWare is, we provide two products, but RackWare provides a fully integrated solution for all your assessment, cloud migration, disaster recovery, and backup needs. Our solution is hypervisor agnostic, cloud agnostic, as well as application agnostic. That means it enables migration and protection of your workloads, be it Windows, Linux, Kubernetes, or OpenShift, from any data center to any cloud, or from any cloud into any other cloud. So it's a true any-to-any solution. As I said, we have two products, RMM and Swift. RMM stands for RackWare Management Module. It is built for servers, both virtual as well as physical. And Swift covers our container platform. So in today's webinar, we will focus on RMM, that's RackWare Management Module. But before we start, let me give a bit about RackWare. We were founded in 2009 in San Francisco Bay Area. We currently operate out of 5 locations, San Jose being our headquarters. Our APAC and EMEA regions are covered by our development and support center in Pune, India. Akash and myself, Sunil, and Paresh, all of us are based out of Pune, India. We have a long-standing partnership with all leading hyperscalers, cloud providers, including Oracle, OCI, IBM, Azure, GCP, and AWS. And we have a huge partner network, which we kind of use to support our customers across the globe. Our solutions are also available in leading cloud marketplaces. Now with that, let's get started with an overview of RMM features and capabilities. I'll hand over to Akash, who will cover the migration and DR use cases. So over to you, Akash.
Yeah, I hope it's visible. So hello all, my name is Akash. I am the Director of QA and Systems Engineering at RackWare. In this webinar today, I will give you a walkthrough of the capabilities and features of RMM, and also how you can leverage the automation and intelligence of the software to tackle the complex problems that are usually associated with migration, disaster recovery, and backup. Now, RMM, which stands for RackWare Management Module, primarily provides or deals with 3 use cases. First is assessment, second migration, and disaster recovery and backup. Now with assessment, RMM allows you to gather valuable information of your workloads that you are planning either to move to your target environment or would want to have them protected or backed up into the environment of your choice. You can discover, analyze, and monitor your applications, your workloads. You can gather valuable data in the form of what are the resources allocated, what are the peak values for those resources, like, when is your CPU peaking or your memory running out of, the available resources, and then intelligently use this data to figure out what would be the right sizing for these workloads to be replicated into the target environment. We also help you have a cost comparison when you would want to plan your move into the environment of your choice. Now with migration, we are a true any-to-any solution. We are agnostic of what your underlying hypervisor or your cloud provider is on the source side, agnostic of the hardware. We just deal with the source operating system and needs to make sure that the operating system version is in our support matrix. The target environment can be of your choice. We have auto provision capabilities, which makes it easy for you to really replicate the workloads without requiring any manual intervention for creation of the target workloads. With disaster recovery and backup, you can protect your workloads in the environment of your choice by creating simple DR policies meeting your RPO and RTO requirements. We have a converged backup solution which helps you create backups, have the point-in-time snapshots so that you can revert either to your primary or to your destination, and can do single file restore as well, helping you protect your workloads from malware or ransomware attacks. Now, like I said, we are a true any-to-any solution. We are hypervisor agnostic, and we really don't care what environment your source workloads are running on. As long as the source operating system falls in our support matrix, we can help you replicate it into the target environment of your choice. And we cover almost all the gamut of public cloud providers that are out there, as well as all the hypervisors that you would find in a data center deployment. We do physical to virtual and all the conferences that would arise as a combination of those. And we are agnostic of any application or database that is running on top of your source machine. So we really communicate with the operating system and lift and shift your workloads. Now, when it comes to migrating your workloads, where RMM can really be handy and make life easy is by providing a good graphical user interface, which is intuitive, helps you configure things with ease. There is a very good predefined workflow as well as documentation available, as well as videos available where you can get a view of how you can really approach the configuration. All the workflows are automated, so you feed in the data once and let RMM take care of the replications as well as delta syncs. All the operations that RMM does is non-disruptive to your source environment. So your source continues to be up and running, no reboots needed, it's a live migration. When we have done the initial replication, subsequent delta syncs can be performed to make sure that your target is always refreshed with the changes happening on the source, making sure the final cutover window is kept to the minimal with respect to the delta sync timings that would be needed. So it leads to lower cutover windows, making sure that you are approaching your production path to the production the fastest way. The workflow is common for Windows or Linux operating systems with regards to configuring it on the RMM's graphical user interface. The prereqs are the same for each of these versions of operating systems, as well as it follows the same path for physical servers. So you understand the workflow once and you can simply replicate it for the rest of the workloads that you would want to really migrate. RMM allows you to do a lot of automation in the form of pre and post scripts. These can be PowerShell or Bash scripts, which can help you automate a lot of manual tasks, like making any configuration changes on the target side, and thereby help you save valuable time during the cutover windows. And once you have the migration use case set up on the RMM server, your workload replicated in the environment of your choice, it's very easy for you to really move to the disaster recovery or backup workflow from this point onwards. Now, when it comes to disaster recovery, the graphical user interface allows you to configure the DR policies with ease. It's very intuitive, asking the right inputs and making sure that the validations are in place. The failover fallback is completely automated by a simple click of a button on the graphical user interface. And we will dig deeper into this when I cover the disaster recovery piece. The dashboard gives you a good view of all the workloads that you are protecting, what are the sync timings they are achieving, their best and average sync timings, so that you can take a view of whether your SLAs are being met or not. You can also generate good reports which can be used for compliance purpose. When it comes to matching your or meeting your cost requirements as well as the performance requirements, RMM gives you a variety of options to pick and choose from for configuring your disaster recovery, which helps you achieve your cost optimization as well as meet the SLAs for the critical workloads. Like I said earlier, the post scripts help you automate a lot of stuff, and this becomes very crucial when you are in a failover situation, right? When you are in a disaster situation where every minute counts, anything that you have already automated is going to help you save time, meaning your machines or your servers will be back up working as production with minimal downtime. And on top of it, you can have backups configured by configuring the retention policies, which can help you recover your workloads in case of losing your data or in case of malware or ransomware attacks. Now moving on, this is a very important slide where you will get to know at a high level how to set things up when you would want to use RMM for any of the use cases that I explained earlier, and how at a high level RMM performs the operations. Now here on the left hand side, what you see is your source or your production environment, which is hosting your virtual machines running in either in data center, or those can be running in any cloud provider, or these can be your physical servers running in the data center. On the right hand side, what you see is your target environment where you would want these workloads to be replicated or protected. The blue box that you see that says RMM, that is the Linux based instance in your DR site or in your target environment, on top of which the RMM software is installed. Now we are present in the marketplace of leading cloud providers like Oracle, IBM, GCP, as well as Azure. And for the other environments, it's very easy for you to really set up the RMM instance, like you spin up any Linux-based virtual machine meeting the prereqs for RMM software, and then the software installation roughly takes 30 to 40 minutes with all prereqs in place. With this RMM instance up and running in the target environment, the first thing we need to ensure is network connectivity between RMM and the source workloads which are to be replicated. Now this connectivity is over L3, meaning RMM is going to communicate with the individual workloads on their unique IP addresses. This communication happens over SSH on port 22. So the only hole you need to punch in your firewall is with regards to opening port 22 inbound from the RMM's IP address. For both Linux and Windows, RMM makes use of key-based passwordless SSH mechanism to communicate with the source workload. So RMM is communicating over a secure channel with your source machine, ensuring the data protection is taken care of. With regards to the network, there is no hard requirement as to what kind of a network you should have between these two sites. RMM can work over public or private networks as well. Now, once this connectivity is in place, the next step is for RMM to go ahead and perform the initial discovery of the source workload, where it will gather information like the operating system version, the kernel version, the resources allocated to it, the disk sizes, and the network config. This basic information is used by RMM to figure out what is the right shape for creating a target virtual machine in the target environment for replicating this workload. We call this as the auto provision operation. With this information available, RMM will go ahead and create the target machine for you in your target environment, boot the target server into RackWare's microkernel, which is like an intermediate operating system, format the target instance completely, create the partitions matching to that of the source server, and then start replicating the data or copying the data from the source to the target. At the end of this, RMM will make sure that the target has got the right set of drivers as well as boot configurations so that it can boot up fine on the target hardware and finally reboot the target into the operating system. At this point in time, your target has been successfully replicated and you can now log into your target machine to perform any validations that you may want to do. Now, given all the replication activities happening while the source is up and running, it's a live migration, no downtime, no reboots needed. The source is continuously processing the production transactions and there are changes happening on it all the time. In order to make sure the changes happening on the source are pushed to the target, we have a very intelligent sync engine which figures out the delta that has changed on the source, and every time you run a sync, the data changes that have happened on the source are pushed to the target, making sure that your target is up to date with the changes that are happening on the source all the time. Also, with multiple delta syncs run in between, it makes sure that during the final cutover, the delta is smaller, meaning your cutover window is kept as small as possible. Moving to the disaster recovery use case, it's very easy for you to move from the migration to DR use case from the graphical user interface of the RMM. For configuring DR, you just need to set up a DR policy from the UI. We have a very sophisticated policy engine which allows you to configure the periodicity of the delta syncs that are to be performed from the source to the target, source to the image and image to the target. For disaster recovery, RMM makes use of store and forward mechanism where a block storage is attached to the RMM instance in your DR site, and this block storage is then used by the RMM to capture a clone of the source server in the form of an image that is present on the RMM's block storage. So the workflow is store and forward. A stage 1 sync copies over the delta from your source to the images present on the RMM, and a stage 2 sync pushes those changes from the image to the target server. Now, based on your RPO and RTO requirements, you can decide on the periodicity of the delta syncs. And of course, you can have pre and post scripts glued together in the sync process to help you save on any manual steps that you would need to do as a part of the failover operation. All of this is highly automated through the graphical user interface. The dashboard gives you a good view of all the sync operations that are being run. You can also get alerts right in your inbox for any failures if you configure your email IDs as a part of the DR policy. And once you configure these DR policies, you just configure it and forget about it. RMM will keep on running the syncs based on the configurations that you have done. Now, when it comes to failover, fallback, or DR drill, all of this is highly automated through the graphical user interface. A simple click of a button on the GUI helps you failover to your DR site. RMM will make sure there are no pending syncs with the target server, boot it into the operating system, make sure that it is reachable over the network, perform preliminary data validations, and at this point in time, other team members can jump in and perform their tasks as part of the failover runbook. With fallback, it is equally automated by a click of a button. When you do that, RMM reverses the direction of sync from your DR site to your restored or rebuilt primary. So both are supported. When you would want to do a DR drill, RMM allows you to do that without disrupting your production syncs happening with the RMM storage. So RMM continues to sync your production with the image that is present in the RMM storage, and it pauses the sync with the target, boots it into the operating system so that the teams can log into the target and machines in an isolated environment, perform all the validations that they would want to do, generate any dummy data, and make sure the tests are all good. Once your tests are done, you don't need to do any manual cleanup. You simply need to resume the DR policies again, and as a part of it, RMM will make sure the target is the same as that of the source. So it's very easy for you to perform the tests and then start over from a clean state again. Now, this slide summarizes what all options you get as a part of configuring disaster recovery using RMM. This is with consideration around your cost optimization as well as your RPO and RTO requirements. The first one here talks about dynamic provisioning. This is the best cost option, the lowest cost, but it also results in the longest RTO. Now, what happens in case of dynamic provisioning is in steady state in your DR site, you will only have the RMM instance up and running with the block storage attached to it, which is holding the images of the source server. And delta syncs are executed from your source server to the image present on the RMM based on the periodicity that you have configured in your DR policy. What happens in the case of failover is RMM will provision the target machine for you as a part of the auto provision environment, boot the target server into RackWare's microkernel, format it completely, create the partitions matching to that of the source, and start copying the data from the image that is present in the RMM's block storage to the target machine. At the end of it, it will make sure target has got all the right set of drivers, boot it into the operating system, and at this point in time, your server is available to you as a production equivalent. So with all of these steps happening at the time of a real failover, this results in the longest RTO. So for the workloads for which RTOs are not a concern, or longer RTOs are permissible, the dev test boxes or any other machines which are not that critical, dynamic provisioning can help you save a lot on your cost in your DR site. The second option is pre-provisioned with the target servers powered on all the time. So this is equivalent to a warm DR that you can configure. The target servers are pre-provisioned in your DR site along with the RMM instance being up and running. And the target servers can be provisioned either with the equivalent specs as that of the source, or they can also be configured for the lower specs. Now, because the target server is almost always up and running, you get the best RTO here because the target server is available to you unless it is in a sync cycle, so it can immediately start acting as your production equivalent. But with the target servers always up and running, the computes and storage being used on your DR side, this also results in the highest cost. So for the workloads which are mission critical, for which you really cannot afford longer downtimes, you should go for pre-provisioned powered on workloads, but it results in the highest cost. A variation of the second approach with pre-provisioned powered on is with your target servers being pre-provisioned but powered off. So the difference in this case is, although you have your compute nodes pre-provisioned in your DR site, those are powered off unless RMM would perform a sync with it. So you can have different sync periodicities set up for the syncs happening from the source to the image and between the image and the target. For the syncs happening between image and the target, you can choose frequencies like sync every day, sync once in a week, or once in a month, depending on what RTO you want to achieve. Now, whenever there is a failover situation, RMM just needs to perform a delta sync with the target because the bulk of the data is already transferred and the last delta syncs have already been run with the target machine. So this gives you improved RTO compared to dynamic provisioning, as well as helps you save a lot on the cost because your computes on the DR side are being used only in case when the RMM is syncing with the target node. So almost always you are going to have the use case where you have workloads which are having different priorities, or which are having different criticalities involved with them. So you can have those segregated into different DR schemes. Some may go for dynamic provisioning, some for pre-provisioned powered on, and others for pre-provisioned powered off. It will help you balance your cost considerations on the DR side, as well as achieve the right RPOs and RTOs for the workloads that you have in scope. Now moving ahead, RMM has got a lot of advanced capabilities up its sleeve, one of which is Selective Sync. Selective Sync helps you pick and choose the files and folders of your choice that you want to replicate to your destination. Most of the times we have archives, backups, or user-specific data that we do not want to be moved over to your destination for the purpose of saving on the storage cost, as well as to make sure you are making effective use of the available bandwidth that you have between the two sites. So the Selective Sync feature really comes in handy for such use cases, wherein you can pick and choose the files and folders that you would want to exclude or include in the sync. You can even do exclusions at the level of drives or folders, so which makes sure that any unwanted file system is not copied over to the target site. You can have multiple policies created so that combining the selective syncs with your DR policies, you can achieve the combinations that you would want to have for your RPO RTO considerations. Now coming to the support matrix that we have, like I said, whenever we are dealing with any migration, disaster recovery, or backup, the only thing that we really need to take into account is what is the operating system version and the file system type that is running on the source server. Now with operating system versions, we support Windows 2008 R2 64-bit up until Windows 2022. For Red Hat and CentOS, we support 5.x up until 9.x, versions 11, 12, and 15 for SUSE, Ubuntu up until version 22, and version 11 for versions up until version 11 for Debian. For Oracle Linux, we support 5.x up until 8.x. Now RMM does all the replications for x86 architecture, so we need to make sure the prereqs are taken care of, the operating system meets the support matrix that we have, and the prereqs that I'm talking about are really simple, like those are the same irrespective of what Windows version you have or what Linux version you have. And we make use of operating system native mechanism to replicate the workloads. So we are working very closely with the source operating system, and it makes sure that the software has minimal impact on your production workloads, making sure that your production continues to be up and running and perform the same way as it would otherwise do. When we are performing backups, you can configure the retention policies which can help you have the required number of backups available in your target site. And you can also do the single file restore, wherein you can restore the files of your choice, files and folders of your choice on the source or your target site, as well as do the entire image restore. So you get a lot of flexibility. Whatever use case you may have, there are a lot of options to help you cater to your specific requirements, as well as the software is really flexible to allow you meet your requirements in the best possible way. With the various options that you get for configuring the disaster recovery, you get to pick and choose the combinations which can help you save on the cost, as well as meet your RPO and RTO requirements. And all of this through a single pane of glass, through the single graphical user interface, really makes it easy for you to manage all the complexities that are involved in replicating the workloads or setting up the disaster recovery on top of it. The licensing model is also very simple and easy to follow. Our licenses are per workload based. So the number of workloads that you would want to protect or replicate, you simply need to have those many licenses bought. Of course, there is a cap on the storage size, depending on what is the size of the data to be replicated associated with the source machine. Now, with all of this in place, I think you have got all the initial information that you can really start looking into for all the migration, disaster recovery, or backup projects that you may have lined up, so that the software can help you approach your projects in the best possible way and in the shortest possible time for your move to the production. So with that, I conclude on the technical coverage that I intended for this webinar. I hope you found this useful. For any further questions, you can reach out to Sunil, and I'll hand it over to Sunil for further closure. Thank you.
Yeah, thank you very much, Akash, for a wonderful presentation. So on behalf of RackWare, we thank you all for attending this webinar and giving us an opportunity to present our solutions. And thus, by now, I believe you have, you know how our product works and how can it be beneficial for your organization from the migration and DR perspective. So I request you all to try our solution whenever you get a chance. We can do POC, we can provide POC licenses. Once you do, I would suggest you to do this, try our solutions and find out its effectiveness and fitment into your solutions framework. For solutions, please contact me. My name is Sunil and my email ID is mentioned over here in the last frame, sunil.dev, D-E-O, @rackwareinc.com. And you can also approach on to my cell number 965-7702-112. So thank you once again and wishing you all a great day and a fabulous time ahead. Thank you everyone.